All right, example 8 tells us to prove this identity here, that cosecant of theta minus sine of theta is equal to cotangent of theta cosine of theta. And so we saw one similar to this earlier. And remember, it's usually easier to take an addition or subtraction problem and combine them to make it multiplication versus take a multiplication and make it addition or subtraction. So I'm going to go ahead and I'm going to work the left side of this again. So let's see what we've got here. Cosecant of theta and sine of theta. Well, I know cosecant and sine are reciprocals. So how about I start with the fact that cosecant of theta then is 1 over sine of theta. And then I can combine them because how do we subtract fractions? Common denominator. So I'm going to multiply the second fraction by the first one's denominator and the first fraction by the second one's denominator. So I got 1, I'm going to just put it together, minus, here I have sine squared all over that common denominator. Well, let's look at what we're after. We don't need any signs in it. We see cosine, and think about it, what do you know about cotangent? Cotangent is cosine over sine, isn't it? So I need to somehow come up with some cosines here on top. Well, what do we know about 1 minus sine squared? Well, we've got a 1 and a trig function squared, so I'm thinking look in my Pythagorean identities, and you'll see that 1 minus sine squared of theta is equal to cosine squared of theta. And then, okay, well, what do we know? Let's see, we need a cosine by itself, we see here. So what if we separate this? Cosine squared, remember, it's the same thing as saying cosine times itself. And so when I look at this, I see, oh, well, there's that cosine of theta that I need. And wait, what is cosine over sine? Well, cosine over sine is cotangent of theta. And then I got that cosine of theta, and that's exactly what we were looking for. So we have proven this identity. So it is demonstrated.